Let's introduce some basic concepts so that we can make sense of the architecture being discussed. An instruction is a specific command that is understood by the processing unit and performs a very specific operation. For example, moving data between two different locations in memory would require a specific instruction to direct the processor to perform that action. A program consists of instructions that perform a particular function. However, programs must also often wait for events to complete before they can continue. For example, if I want to read data from a file, the program will initiate the request to the disks through the operating system and then wait to be notified when the data has been moved from disk into memory. As a result, multiple programs running on a processor will result in one program having access while others are waiting. If another program becomes ready to run again, then it must wait until the program currently running gives up control. So, with this as a backdrop, let's begin by examining the System Z processor itself, the EC12. The EC12 consists of 25.5 GHz hex core processors, or 120 processing units. Of the 120 processing units, 101 of them can be configured for use by the operating system to run work. Each processor is responsible for executing an instruction stream, so we can see that with this configuration, up to 101 units of work can execute simultaneously. This dramatically improves throughput by allowing more work to run in parallel, thereby minimizing the amount of time that ready work has to wait for a processor to become available. The remaining 19 processors are divided up as one reserved, 2 spares, and 16 system assist processors, which we will discuss shortly. In addition, the System Z machine can be ordered as one of 5 models that offer reduced sizes for customers that don't need as much capacity. In this table, we can see the various models and the breakdown of the available processors and their assignments. There are also 2 types of specialty engines. One group consists of those that can be configured for special use by the operating system, while the other represents processors that can be assigned other exploitation roles. The purpose of the first group of specialty engines is due to marketing rather than technical requirements. Since software licensing charges are based on the capacity or size of the processor, then having a configuration larger than is strictly needed can increase the cost of the software being run. To offset these costs, IBM reduced these specialty engines which could run selected work but not be counted as part of the capacity for software licensing purposes. In the first group, there are 2 specialty processors that can be used by the operating system: the Application Assist Processor, or ZAP, and the Integrated Information Processor, or ZIP. These processors are used by specific types of work that the operating system can then select to be run on them. In particular, these specialty engines are used to support various database types of work as well as supporting Java. The benefit of this is that it allows qualifying work to be directed to these specialty processors and frees up capacity on the general processors for other work. The other specialty processors are the internal coupling facility, which is used to implement the parallel sysplex to provide high-speed communications and data sharing between systems. The System Assist Processor, or SAP, are processors dedicated to the channel subsystem to manage and drive I/O operations. The Integrated Facility for Linux represents processors that can be used to run a virtual machine environment, VM, to support multiple Linux virtual machines. Virtual Machine is a separate operating system that supports running multiple Linux images. While some of these processors may be required to fulfill technical requirements, as noted previously, their presence does not contribute to the capacity considerations of the processor with respect to software licensing charges. This slide is a screen capture of a performance monitoring product that runs under ZOS. It is included here to illustrate how the particulars of the system can be displayed to show what the utilization of the physical system is. If we look at the 4 lines at the bottom, we can see that there are 3 general processors, or CPs, and 1 specialty engine, or ZIP. Only 2 of the processors are online and in use in this example with a low utilization of only 4 to 5%.